Welcome to my session. Today, I'd like to talk about the Egison programming language. Today's my presentation purpose is to get you find Egison is an interesting programming language. First, let me introduce myself. I am a researcher working for Rakuten Institute of Technology. I have interest in theoretical computer science, especially in the theory of programming language. I've been designing and developing the Egison programming language since I was a university student for 4 years. And now, I've been searching application of Egison in the real world in Rakuten. Next, I would first like to introduce Egison quickly. Egison is a programming language with various pattern matching facility. We can express pattern matching even against the data that have no standard form. In the sample code, we are enumerating the elements that appear more than twice in the target collection. If we write it in Ruby, we need to write nested for loops and conditional branches. If we write it in naive way without using the library function. But if we write it in Egison, we can write the same meaning of code in a single pattern matching expression like this. The expressive power of Egison pattern matching is so strong that we can write poker and pattern matching in a single pattern matching expression like this. Egison is the world's first programming language that can do such kind of thing. We can write patterns even against margin. This code investigates whether margin has finished or not. The third demonstration is sample from elementary mathematics. We can enumerate various kinds of combination of prime number using pattern matching like this. The first pattern enumerates twin primes. Second enumerates 6 primes. The pair of prime numbers difference is 6. Third example enumerates prime 2 primes. Here is the reason why I created this language. I created this to represent human intuition directory. As you know, the word intuitive is often used in the meaning easy to understand. However, intuition itself is not intuitive at all. Therefore, the direct representation of intuition is not easy for many people to understand at the beginning. The thing is, there are cases that we still need to translate our software computers. By discovering such cases, analyzing our intuition, and finding their direct representation, I have created this language. Here is a profile of Egison programming language. As you can see, Egison is open source software maintaining on GitHub. Currently, Egison is implemented in 3,800 Haskell code. We have our website. We have written everything about Egison in this website, including today's contents. Please take it too. And this is the end of quick introduction of today's contents. Here is a table of content of today's talk. First, I'll explain the concept of Egison. Second, I'll share current status of Egison. Third, I'll share future plans. Finally, I'll play with Egison here. Then, let me explain the concept of Egison. Let me explain the syntax of Egison's pattern matching expression. We can introduce the concept of Egison with this match-all expression, only with this match-all expression. A match or expression takes a target and a matcher and a match clause, which consists of pattern and body, which is executed when against the result of pattern matching. The meaning of this expression is pattern match against a collection 1, 2, 3 as a list of integers. Return once excess and return all results of pattern matching. Let me explain about matchers. A matcher specifies ways of pattern matching. In these three examples, the matcher is only difference. First expression matches the target as a list of integers. Second matches as match set of integers. Third expression matches as set of integers. Please note that if the matcher, if we specify a different matcher, the result of pattern matching changes. Even if other components of pattern matching expression is same. This pattern constructor divides the collection into an element and the rest. If we matches the target as a list, cons divides a target collection into a head element and the rest. If we matches the target as a match set, cons divide a target collection into one of the elements of collection and the rest of elements. If we match it, this is because match set ignores the order of the element of the collection. If we match the target as set of integers, cons divide the target collection into one of the elements and the collection itself. This is because set ignores not only order of elements, but also duplication of the element in the collection. Please also note that we can handle multiple results of pattern matching. This is necessary feature to realize pattern matching against data such as match set and set, which has many ways of decomposition. We can write patterns with nested pattern constructor like this. This sample extracts two elements of the target collection to the nested pattern. We have another constructor join. It divides the collection into two collections. There are multiple ways of decomposition, even against list, if we divide them using join pattern constructor like this. It divides head of collection and tail collection. We can handle multiple occurrences of same pattern variable in a pattern like this. Patterns that begin with comma are called value patterns. The equality is checked for a value pattern. We can define the equality for each data type in the matcher. This sample pattern enumerates the element that appears multiple times in the target collection. In this case, 2 and 3 appears multiple times, so this pattern is 2 and 3. This nonlinear pattern, this pattern is called nonlinear pattern. This feature is one of the most critical features of Egison. Nonlinear patterns are one of the very strong excess power. Thanks to that, we can write four-count pattern match in a single expression like this. Now let's investigate each pattern of four counts. Please note that we are pattern matching against the collection of cards as match set of cards when we return four counts. This is pattern for straight flush. all 5 cards has same suits. And this means for number of cards here are in sequence. We can write like this. We can write to any expression after comma. So we can express the various pattern using nonlinear pattern. And next, we let to investigate in pattern for 2 pair. It's like this. This means we don't care the suit of cards and but the kind of fifth element. This part represents there are two pair of cards that has same number. Like this, we can represent all poker hands in a single pattern. Programmers who master the Egison can write this program like this very quickly. If we really write it in Java, it's very complex. Even if we just find a pair of cards, we need to write a nested ball and constant branches. And all code, total code is hard to read. It's difficult to find bugs from that code. Let's move to the next sample. This sample is against an infinite list of prime numbers and extract all 10 primes from that using pattern. This 10 primes we extract first head element from the graphic pattern. We get first 5 twin primes with this expression. If we change the pattern like this, we can extract various combination of prime number. If we use join and cons, we can represent various patterns. So this is my favorite program in Egison. So I display it on the top page of the Egison website. Let's check it too. Let's move to next. We can pattern match also against nested collection like this. This sample enumerates common elements among the collection in the given collection. We have a function to modularize the useful pattern and modularize useful patterns. We can modularize patterns with pattern functions that only receive patterns and return patterns. This sample modularized pattern that matches two same elements in the collection. A pattern function has lexical scoping, so pattern can be used in a program without value name clash. Actually, to build theory for pattern modularization with lexical scoping is the hardest work in the design of Egison. Applying pattern modularization, we can write a program that determines whether merger and finish or not, like this. We modularize the pattern for two same tiles, 3 consecutive tiles, 3 same tiles, like this. And combining that pattern function, we can write patterns that determine whether direct merger and finish or not, like this. Then I'll share current status of Egison. This year, I have concentrated on improving of my presentation for Egison. I've updated the Egison website like this so much. this is kind of hardware calculation. We've implemented online tutorial. We can learn basics of Egison here, including basics of functional programming and pattern matching. We also prepare the demonstration page of Egison. We can edit and run Egison demonstration program online. All the demonstrations I explained in this presentation are online. Thanks to that Egison has been getting popular gradually. This April, Egison was chosen as one of the 10 package program language authorized by InfoWorld, one of the most popular information technology, one of the popular information technology online media. In June and July, Egison was discussed on Hacker News twice. It was discussed very hotly. Egison's thread was on the top page of Hacker News in a whole day twice. Recently, I got a chance to write an article on Code IQ magazine, one of the popular online media in Japan. I've described my reason to create a new programming language here. Please take it too. And surprisingly, Egison will be taught at the University of Tokyo. I believe Egison will have a big impact on the academic world too. This is the access map of Egison in the last half year. People all over the world are checking and visiting Egison website. This year, Egison community has grown up very rapidly. Before last year, Egison was watched only by my friend. So Egison exists for 4 years. But now people from all over the world are checking Egison. To propagate Egison more, I am working to extend other languages to access Egison pattern matching. I have already implemented Ruby extension. This is poker hand demonstration in Ruby. Ruby extension is written in pure Ruby code. I wrote an article on Egison Ruby extension of Egison in Japanese online. It has very good large reaction. And I talked about it in RubyConf 2014. There are more than 300 audience. There are good reaction too. Finally, I'd like to talk about future plans. Actually, there are a wide range of applications of Egison in the real world. First, actually, Egison makes daily programming very easy. And this is ideally and this software flying Egison pattern matching. Actually, some of them I've already implemented, and I'm using it in daily life for Rakuten. And I hope it will apply in Rakuten. For example, if we apply Egison for text processing, we can do what is impossible even if we use data expression. So we can do our area on command line, not using Excel, not writing program. Next chat analysis. If we use Egison, we can find the class pattern from chat very easy. And I explain later, but Egison is very good if we use it as query language. Next, I explain about it. I will show demonstration of Egison query. Let's consider query that returns, let's consider Twitter social blog and consider the query that returns Twitter users who are followed by me but not followed by me. And this is the table information. If we write it in SQL, the expression is very complex and difficult to understand if there are no comments. Please look inside the where clause. It's very complex. Furthermore, it includes not exist a subquery. If we write it in Egison, the expression is very simple. No where clause, no subquery. If we can read Egison, we can recognize what this query do at once. Let's investigate one line, each line. First, we join table user, pro user, and in the first line of pattern, we get the user ID whose screen name is here, and bind it to the variable UID. So in the second line, we get user ID who are followed by me, matching against pro table. Third line represents there are no reverse records in the pro table using not pattern. And fourth line gets the username of that ID who don't follow me. And final line returns that result. Because of nonlinear patterns, we don't need to write where clause. Like this. And, I'm thinking that we can create a GUI tool for intuitive data analysis because query in Egison is very simple. Therefore, we can design GUI to construct Egison queries that everyone can use. I believe this can help work in the real world. And let me talk about more future. In the future, database, I think database will be embedded and hidden behind programming language. We will be able to handle databases directly and easily just as arrays and hashes in existing language. I believe Egison, which has built in strong pattern matching expression and doesn't need DSL such as SQL, will play a critical role for this future. And from 14, Hara-san, my teammate in RIT, will talk about this new DB project from RIT in this room. Please check it too. Next application is natural language processing and image processing. Egison can deal with complex data structure intuitively, so it makes this kind of programming also easy. And this is my dream. In fact, my motivation to create Egison is to create programs that automatically build math theories that find interesting things and automatically generate programs. To realize that, I thought we need the direct representation of our intuition. So I studied that. Finally, let me talk about the position of Egison in the theory of programming language. We can divide the field of theory of programming language into three parts like this. First is mathematical abstraction. Research in this field enables us to write programs directly without translation for computers. Second is computer abstraction. Research in this field enables us to operate computers in easy way. For example, memory or distributed computing. Third is human understandability. research in this field makes it easy to learn and use programming, easy for many people. So I created some concentrating on this field. Research for all field is difficult, but this mathematical abstraction is a very big field and the most difficult field to get a new idea. And this is a more detailed mind map of the theory of mathematical abstraction. And Egison pioneered the field of pattern matching. There are already advanced research on pattern matching before Egison, but they are still not strong enough as Egison. There are only primitive pattern matching in major programming language. Egison is the world's first language that realizes all features here are listed, and I'll explain in this presentation. And extend the excessive power of pattern matching so much. And I think the theory of Egison is really a historical innovation in the history of computer science. And I'd like to the theory of Egison known by many people all over the world. And I am also aiming to make Egison the perfect programming language. And please try use propagate and support Egison for that site. Thank you. I'd like to demonstrate the Egison program here. If you have any question, please ask me.
Why did you choose Haskell to implement Egison?
This is because it was the easiest way I've known at that time to implement new language interpreter. And the best language I've known at that time, because Haskell has pattern matching and have great pattern library. So it was very easy to implement new language interpreter in Haskell. I demonstrated Egison interpreter. If we install Egison, we can call Egison interpreter from command line with Egison command. So we can write program. Example. Here we are we can addition. We have this. We contain present library prime number, in interest of prime number, and take function which extract head element from the collection. Let me demonstrate pattern matching. I'll extract 10 primes here. We match primes as a list of integers and pattern is 3 and 3 plus 2, like this. And you have two implements are so many, so I extract first 20 two implements like this. We can extract two implements. If this program is very short, for example, if we change it to P plus 4, we can get cosine plan like this. If we would like to get to 60 plans, whose difference is 6. There is a possibility that there appears other prime number between P and P plus 6. So I had to join pattern constructor between them. And we can get 6 times like this very easily. We change here too much. There is a prime number P plus 2. We can get prime trumpets like this. And this is the only we can have any kind of pattern like this. We get from quadruplet. Egison has a script mode, and we can call it using IO command on the computer. We print all prime tuplets. We can print all prime tuplets like this. This program animates the prime triplet when it is this stage when the program get a new combination. We prepare Emacs mode for Egison, and we can write script using that. We need to define main function like this as ordinary other languages. So we call this program using main Egison command on the command line like this. And it does the same thing. I'll demonstrate that. Egison pattern matching is very useful when we write a complex text processing program in daily programming. So please try it. If there are any requests for demonstration, please tell me.
So I have one question. So if I want to learn the syntax of Egison quickly and I install Egison, what should I do?
Yes, thank you for good question. We also provide Egison tutorial command. If we call Egison tutorial command, Egison tutorial command, we get one step-by-step tutorial of Egison on the command line like this. We can Egison on terminal 151 like this, step by step. I have prepared exercise, part of the tutorial, and maybe it will be interesting to try. Please try that too. Thank you. Are there any requests or questions?
If I have my code, like on Java or PHP, and I want to use the Egison functionality for pattern matching, is there any way I can integrate or get this functionality from Egison to my code?
The currently prepared only way is to implement Egison, to call Egison using the shell command.
So I have to call on shell command and that's
yes.
The data from
yes.
text.
It's the current I prepared.
You use indent in example code, and
yes.
Is it just easy to see, or is it necessary like Python language?
It is not necessary for as a Python language. It is not just for display, print display.
Okay, thank you.
Do you have the milestone or Egison?
Yes. Thank you for this question. I've made it open to public milestone Egison. And put a plan. Also, the date of the implementation is not decided. And I explained it. In fact, Egison does not have module system for now. So I'm thinking I'd like to implement it in future. And my future, I think I'd like to implement the type system in Egison as other functional programming language like Haskell, Camel. And after that, I'd like to implement make it able to integrate with other language like Haskell, Java, or Haskell or Java function from Egison, or Egison function from Haskell or Java like this.
I see that one more improvement. You see kind of expanding the language from a few other perspectives, but I didn't see anything related to performance. So for example, you say about instead of using cycle language, using Excel. But when you use a cycle language, a database to make the search engine constructs a strategy so that it will use more indexes and etc. So if in the example of prime numbers, it's kind of a sequence.
Yes.
So it's easy to keep performance because you don't need to go back on the same. In the example of the overlap hand, you maybe need, if you have a large set, you need to compare back. I don't know.
Yes.
So and you are using, for example, your Rakuten integration, another language, so probably you need to have the other one also to be. So it seems kind of this will be big challenge on the performance part. How do you plan to kind of bring performance? Because to use it on real world, you kind of need to solve a lot of performance. Because for representing the syntax, what is the problem for a machine? Okay, you get a very nice syntax, but to really execute this, maybe the cost of performance will be worse than writing more code.
Yeah.
So how do you plan to solve this problem?
Yes. First, I show you some code for explanation. We specialize matchers by pattern matching, and we can define matchers by our hands. And it describes how we pattern matching. So if we define efficient program, efficient algorithm behind matcher, the performance will be good as we handle this efficient program.
It's not easy kind of question because it's not only the match, it's how you structure to get the collection you're comparing and then order you do this. So it will be difficult to kind of try to come up with some example that will very much later. Just I think it will kind of that's something related to if you can kind of write code for a matcher, it's very
When we write a program for diagrams, I'm afraid it is not as it is answer for your comment. When we write the application in Egison, we first write a prototype program that we write it naively in Egison, and after that we can make it efficient, customizing matcher or pattern more efficient. as defined in Egison.
In Egison.
Yes.
Can we see the code for?
Yes. On website, we make it public. It's all library function. This is list of we define where pattern matching for each pattern constructor like this. Now for cons, when we pattern match against cons with list matcher, the cons get two arguments, and the first argument is matched as A, which is the element matcher, and the second argument is matched recursively as list of A. And the next target is head element and rest element. In the case of match set, this definition of cons. In that case, cons also has two arguments, and the first element is matched as element of matcher, and the second is matched of matcher. And the next target is calculated using matchable function. We match against target. It's a collection. For example, 1 to 3, collection 1 to 3. This joining and cons pattern. And we get element X, another element X, and other S collection, HS and TS. And we return X and HS and TS. And this is the next target. Like this, we define matcher.
I would love to one day see comparison of performance between different languages and Egison doing the same thing. Do you have plans to maybe put something like that on the website using large data sets that were read from disk?
I don't know.
Okay. Maybe someone else in the community will.
Excuse me. Thank you very much for the presentation. And after that, from 13 o'clock, we have the presentation from Nikki. So please finish this session and please move to the fourth floor. Thank you very much.
Thank you very much.
Thank you.